Good day, everyone. My name is Adolben Malabago Jr. of BS Math 1B, and so today I'm going to be discussing to you the lesson 3.4 of the subject Descriptive and Inferential Statistics, entitled Uses of Measures of Central Tendency, specifically the uses of three measures of central tendencies, which are the mean, median, and mode. I'm pretty sure that you have encountered the three words I mentioned earlier, the mean, median, and mode, during the lessons you had, or during the math lessons you had in your elementary or high school years at some point. So I think you have solved problems involving mean and median and mode before. So I'm pretty much sure that this topic will gonna be easy for you. But before anything else, I'm sure that when you think of mean, median, and mode, you probably heard also the word average. Like your teacher discusses the mean, it usually associates with the word average as well. So, what comes to your mind when you think of the word average? Maybe if you're thinking of the word average, you might referring to an average person or the average of your grades or the average heights of the plants. So there are many things that you can associate the word average in the real world. And so the word average actually connects with the measures of central tendency. So here, average, the uses of average occurs regularly in our daily life, and it is important tool in statistics. It involves a single number or representation that describes a given set of data. There are different types of averages, which we refer to as the measures of central tendency. And the measures of central tendency has its own definition. A measure of central tendency is a value that represents a typical or central entry of a data set. So basically, this measure of central tendency or the average is a single value that describes a certain set of data, and sometimes just represents as one number. So here we have the three measures of central tendency that I have mentioned earlier. So there are three such measures that we commonly use in descriptive statistics: the mean, median, and mode, and it has its own definitions as well, which are pretty straightforward and easy to understand. So here we have the definition of mean, the sum of data entries divided by the number of entries. And it is the most used measure of central tendency, which I think most of us have used already, have computed the mean of a certain data set. Here we have also have the median. It is the midpoint or the minimalist data of an arranged data array, which is usually from lowest to highest, and then grab the middle data out of it. And we also have here the mode, the data entry in a data set with the most frequency. So when do we actually use mean? So here, mean is used when a given set of data is an interval or ratio or that involves numerical data. And in using mean, there should be no presence of extreme values or outliers in a data set. So basically, when we're given a certain set of data that are numerical, we can use the solve mean to identify the average, as long as there are no outliers in that data set or the extreme high values or the extreme low values that we wanted to avoid that in solving the mean. So we have here an example of using mean in a real life example. So here we have example number 1. Dana took 5 100-item midterm exams and earned the following scores: 98, 95, 99, 93, and 93. What is her average score from the 5 exams? So here we are given a numerical data set. Or specifically, there are 5 data that are shown here with the corresponding scores that Dana had. And so we know that mean has its formula, right? So here, the formula for mean is given by mu equals the summation of x over n, where n is the mean or the population mean, is summation of x with this e symbol called sigma, where it is the sum of all data values in a data set, and n, where it is the number of data values in a data set. So if we're going to use the formula, we have to identify how many data are there in this data set that we have the example number 1. And so in solving for the mean, we have here the solution. So mu would be equals to the summation of x over n, where the summation of x is basically the sum of all the scores that Dana had. We have 98 plus 95 plus 99 plus 93 plus 93 all over 5, since there are 5 exams. That's basically the value of n in this example. And so the sum of all of these 5 numbers, 98, 95, 99, 93, 93, is basically equal to 478. And so the mu would be equals to 478 divided by 5, which we get 95.6. Thus, her average score from her 5 exams is 95.6. That is the mean of the data set we encountered in this example. We also have here another example, as we have example number 2. The heights in inches of the players in a basketball team are listed as follows. So we have here the table and the heights of all the basketball players there. And question is, what is the mean height of the players? So basically similar to the example number 1, we're going to use the formulas mu equals sigma, summation of x all over n, to solve for the mean or the average of the data set. So here we have mu equals the summation of x over n, and then the summation of x is basically the sum of all the numbers that are shown in the table earlier, since those are the data within the data set. So we have 74, 78 plus 81 plus 87 plus 81 all up to like 73. And so we have to make sure that we actually add all the scores in this example. And then all over 15, since there are 15 basketball players as shown in the table. If we count the number, or if we count the heights of the basketball players, there are actually 15 the basketball players inside that table. So we have here mu equals the sum of all 15 numbers, which is 1,193 over 15, which is approximately equal to 79.53. Thus, the mean height of the players is 79.53 inches. That's basically the mean of this data set. So if we have the mean, or if we have the mean, then when we actually use the median, is there any difference when using median compared to the mean? So here, median is used when a given set of data is a interval or ratio, like the mean. It is also used when data variables are ordinal. However, median is most preferred when there is a presence of outliers in a data set. So basically the difference between the mean and the median is that mean is used when it has no outliers or extreme high or low values in the data set, while median is used when there is a presence of at least one. So here we have an example in example number 1 for median. Laura wanted to know the average salary of all her teachers in her subjects in school. She then acquired the following salaries for her 10 teachers as shown on the right. So we have here 28,400, 34,500, these 5-figure numbers here, the salaries of Lori's teachers in pesos. And so the question is, what is the average salary of her teachers? And so we might curious if in this example under median, why would we use the median? Why we can't use the mean instead? So basically, if we observe that when we look these following salaries, we observe that most are 30,000 plus. So that's basically we're seeing the average of the salaries of teachers. But we also observe that there is a salary that is as low as 12,000, 11,000. That's that's very different compared to the salaries of other teachers. And so we can consider those as the outliers of the data, since it's extremely low compared to most of the average salaries here. So for the solution, and there's an explanation here, since there is a presence of outliers, that is the two extreme low salaries, 12,400 and 11,100, as I mentioned earlier, we opt to use median to find the average of all the given salaries. So we're going to use the concept of median here, where we're going to arrange the data set. So arranging the data set in increasing order, we have from 11,100 as the lowest value up to 36,400, which is the highest salary among 10 teachers. Since the data set is even, we will get the mean between the fifth and sixth salary to get the middlemost data. So basically, when you're solving for the median, you're gonna identify first whether the data set is even or odd. Because if when it is even, we have to identify the middlemost by getting by getting the mean of the value on its left, and then right, and then divide both numbers by 2 in order to get the middlemost data. Well, if the data set is odd, we can basically just get the number directly, since that we can actually count from the last until the middle point on getting that certain value. And so, hence, the average salary of Laura's teachers is 31,500, because here we have the even data set. So there are 10 numbers, and basically the middle number from 1 to 10 is actually 5.5. So basically, we need to get in order to get the median, we need to identify the fifth and sixth number. But in this example, since both fifth and sixth number is 31,500 pesos, basically the middlemost would still probably be 31,500, even if we get the mean of both of these numbers. So they're basically just the same. And so here's a further explanation on that. If we use the mean in getting the average of the 10 salaries, we have here the mu, which is the mean, and then we're going to use the formula summation of x over n, which is equals to 281,700, the sum of all of those summaries divided by 10, which is equals to 28,170. And as you can see, it's a little bit less compared to what we had the computed median earlier, which is 31,500 pesos. And that 28,170 pesos is less accurate compared to 31,500 peso average salary we get from the median, since only less than half of the data set satisfies the computing mean. So as you can see in an example earlier, most of the data value or most of the data in this data set has like salary of 30,000 peso plus. So, at least six or actually seven numbers here are more than 30,000. And then if we can identify using the mean here, it's only 20,170. So it doesn't make sense if you're going to use the mean. So it's best opt to use median here, since we get 31,500, which is more than 30 plus, and it's kind of close to most of the data within that data set we have, for example, for the first example. So that's basically the importance of median. If there is a presence of outliers, then we need to use median in order to get the most accurate average out of a certain data set. We also have another example here. So Ashley conducted a survey and asked 20 people about their level of satisfaction with the recently concluded intramural celebration at their school. She asked them to rate it according to the following scale: very dissatisfactory, dissatisfactory, satisfactory, or very satisfactory. After gathering the data, she had the following results. So we have here the table, as you can see on the screen. And so we need to find the median rating of this survey. So how do we get the median rating of this survey? So since the variable of the dataset is ordinal, which I have mentioned earlier during the presentation, we can use the concept of getting the median. Given the frequency of the respondents, we have here the arranged array of data of increasing satisfaction. And then since the dataset is even, we shall consider the 10th and 11th rates in the order of increasing satisfaction to get the median. So we just did the same method as we had in example number 1. And since the 10th and 11th person in the arranged dataset rated dissatisfactory, thus the median rating of the following dataset is dissatisfactory. So basically, when the dataset is in ordinal, we can use the concept of median in order to get the median score or the median rating of a certain dataset. And this is actually one of the ways we use median here. And there's also another example or another instance where we use median. So here is example number 3. A group of 17 students took a midterm examination and had the following scores in ascending order. And thus here are the scores that are already been arranged. And what must be your mark to surpass the score of at least 50% of the given class? So you might ask, why do we use the median here? So median is as mentioned and as defined as the most minimalist data. And that minimalist data is basically the 50th percentile of the data set. When we say 50th percentile, that's basically also the middlemost. It is found in the middle since it's 50%. So the upper 50% of data is basically 50% of all the data set, while the lower is also 50%. So that's why we're using the concept of median here to get the mark or the middlemost mark that we need to look in order to surpass at least 50% of the given class. So here's the solution. The mark indicated in the question is the median of the given set of data, since it divides the set into two different sets with at most 50% of data on both sides. Since the data set is odd, we can directly find the minimalmost score or median of the given data set. Since there are 17 values, the median would be at the ninth value of the dataset, or 86. Thus, to surpass at least 50% of the scores of the given class, you should get at least 86 or more. So, if we're going to go back to the data set here, there are 17 scores. And then 17 is an odd number. So basically, there's an odd number of data in this data set, and when we get the odd, we actually we can see actually where the middlemost data is, and which is basically the ninth value. So if we're going to count from the first number 56, the ninth value would actually be located at here at the rightmost, the lone score there, which is 86. So that's basically the 50th percentile of the data, which we need to surpass in order to be higher among 50 more than 50% of the class for this example. So after the median and mean, when are we actually going to use mode? So, or when to use mode in getting the average of a certain data set? So here, mode is used when a given set of data is nominal. It is also used when you want to identify a value from a dataset that occurs frequently, though used sparingly. So compared to mean and median, mode here has a bit of a different definition here. First, in the first sentence, mode is used when a given set of data is nominal, so it's not does not involve any numerical value. So basically what nominal means is it's like categorical, this or categorical, or involves some sort of a qualitative value like that. So that's one way to use mode. And on the other hand, it is also used when you want to identify a value from a data set that occurs frequently. So basically when you see a number or a thing that it repeats accordingly in throughout the data set, that's when you identify the mode. That's basically the mode of that certain data. But I'm going to explain later why it's used sparingly in getting the average of a certain data set. So here we have example number 1 where it tackles we use a mode when the variable of the data set is nominal. So here in an orphanage, Mary asked 100 children to write down the one gift they wanted to receive on Christmas Day this year on a piece of paper. After collecting all the papers, Mary tallied each gift written and made the following bar graph. So we have here the bar graph of the children's wish list frequency. So we have here 5 gifts that children wrote, and here are the respective frequencies of such gifts. So we have we have ball, teddy bear, dollhouse, Lego, and toy car with their corresponding number in the graph. And so, what is the most frequent gift children wants to receive on Christmas Day? Actually, in getting the mode of a certain set of data, it's pretty much straightforward since you're gonna look which gift has the most frequency here. And so the solution here is pretty straightforward as well. In a given bar graph, 25 children want the toy car. So if you look back at the graph, you can see that the toy car hits one line 25 here in the graph, and which has the highest bar among other toys. So as you can see in the graph here, it's basically the highest among all other toys. Hence, a toy car is the most frequent gift children want to receive on Christmas Day. So basically, most of the children wanted to receive a toy car, as shown in the wish list frequency in this graph. So here we have another example of getting the mode of a certain data set. And we actually derive this example from the example number 2 when we are solving for the median. So here, given the survey results Ashley had from example 2 for the median, what is the mode rating or the most frequent response of the survey? So compared to solve getting the median of the data set, getting the mode here is actually pretty straightforward since you're going to look for the most frequent data that is stored in a certain data set, and that's basically the mode of that data. So here, on a given data are dissatisfied with the celebration, which earned the dissatisfactory rating the highest frequency among other ratings. Thus, dissatisfactory is the mode rating of the survey. So that's actually how easy you get the mode of a certain data set. And here's another example that we also grabbed from the previous example. So looking back, or this is the example number 3, looking back on the heights of basketball players on example 2 for the mean, what is the mode or the most frequent height among such players? So here we have the height of basketball players with the corresponding numbers. And as you can see, there are some numbers that are the same. And so if we're going to look at the explanation here, from the given dataset, there are 3 players whose height is 80, and there are also 3 players whose height is 81. Thus, the mode height among basketball players is 80 and 81, which is we consider to as by, no, by model. When we say by model, um, by model is where there are 2 modes in a certain dataset. Since there are 3 80s, 80, or there are 3 players whose height is 80, and there are also 3 players whose height is 81. So that's basically the modes of this data set. Since they have the same frequency of each respective number, we consider them as like the rep that both numbers represent kind of like represent the data set as the most frequent. So here, so we have a bimodal answer from this example. But I'm going to explain later why we sparingly use the mode in getting the average of a certain data set through the measures of central tendency. So after the examples we had earlier, we're gonna have we have some we here are some insights of the uses of the mean median mode in getting the average of a certain data set. So from the discussion that we had earlier, average represents a data set, whether it is a description or generalization. So if you if you read the definitions earlier that I have read or shown in the screen, um, average is used for description. As you heard earlier, in descriptive statistics, we use mean, median, mode, which basically we like describing a certain set of data. That is where the description goes in, or we basically generalize something about a certain set of data. It's not merely getting an inference, but we are just describing through a single number. So that's basically the whole concept of average. And in the real world, we use average in many types of examples. It's basically everywhere, whether numerical or whether you are referring to certain items. And that's where we use average all the time. So, or like instead of identifying uh, the item or number individually, we then instead summarize everything into a single number or a single thing that basically generalizes what we observe. And so here, in the second insight we have is like the measures of central tendency, meaning median mode, caters to different data sets for their own purposes. Yet some will be more useful than the others. So there's basically a difference between when you're going to use mean, median, mode. So there are differences, and sometimes one is better than the other depending on the condition. And so here, median is best used when the data is normal. So when there's no error in that certain data set, we can freely use the mean and get the average of that data set. And, or yes, and either we are assumed to be normal or not. While the median is used when the data is skewed. So when we say skewed, that is when the data set contains outliers. So basically, those outliers that we had are basically the implications where the data is where when a certain data set is skewed. And so why we actually use the mean, I mean, why would we use the median when the data is skewed? Basically, if we use the mean in solving the average of a certain data set with outliers, those outliers would actually the mean on stretch the mean out of the actual values that compiled near the on the most frequent number there. So when there's a presence of outliers, and then when you go to solve for the mean, the actual mean of the more accurate data would actually be stretched because of the outliers, whether it is in the high number or the low number. So that's why when there is when the data set is skewed, we're more encouraged to use median, since median technically does not let the outlier affect the middle score or the true average of a certain data set. So that's basically the difference between the usage of median and mean. And so here, for another insight, mode is a quick approximation of an average. Only represents a part of the data set. We're focusing only on a single data value. So the reason why mode is used sparingly is because mode only represents only single data set that can the mode actually does not represent the entire data. It only cares for what is the most frequent on one certain set of data. I guess we can say that in some cases we can use it to generalize a certain set of data, but we cannot utilize mode for some cases because it only focuses on a single value that is either it could be the mean, or it could be the highest value in the data set, or it could be the lowest value of the data set. Sometimes mode is not really the best to, get a description of that certain set of data. And so here we have a short activity after having those insights we had from the examples and descriptions we discussed earlier regarding the use of mean, median, and mode. So here, the directions. So you have to identify the mean, median, and mode of the following data set of typing speeds, or words per minute, of 11 stenographers, and tell which measure of central tendency best represents the given set of data with an explanation. So we have here a table of typing speeds of stenographers in words per minute. So we have here 125, 140, 170. If you count those numbers, there are 11 of them. And basically, I want you to solve for the mean, median, and mode of these examples. And I want you to identify which measure of central tendency best represents the given set of data. And of course, you have to provide with your own explanations as well in getting this activity. And so you may submit your answers through the email address shown there. We have my CTU email, so you can feel free to send your answer through that email. And so that is our presentation. So thank you for listening in this lesson. which is the uses of measures of central tendency. So I hope you learned something from my discussion, and thank you, and God bless.